time in the exam, I said, what is the meaning of cumulative properties? I don't know, we spent 3 lectures talking about it, but I really don't know what's cumulative properties. Properties of solutions depend on what? The concentration. How many particles are dissolved? I don't care if the particle is big, small, tiny. I don't care about the nature of the particle. Could be an ion, could be a molecule dissolved. I don't care. What do I care about? How many? How many? There are 4 colligative properties. The first one, vapor pressure lowering. Due to what? Due to the solute present. Vapor pressure lowering. Due to what? To the solute present. What kind of solute we're working with? Non-volatile solute. What do you mean by volatile? Just volatile. Alcohol is volatile. Alcohol does what? Evaporate. Alcohol is volatile. Volatile means what? Evaporates. Am I working with things that evaporates? No. What I'm working with? Things that not volatile. Like what? Sugar, table salt. Table salt, you put it in water. Table salt does not evaporate. Sugar does not evaporate. So I'm dealing with non-volatile solid. And people say, teacher, how about if I put alcohol in water? I said, that's another story. We'll get to that later. But right now, I'm working with what? Non-volatile. Think of sugar in water. Okay, let me go if you already have your beaker. This is just water. Water is evaporating. All these molecules on the surface are water molecules. Watch here. I am dissolving sugar. So some of those particles are what? Sugar. Will the water have the same chance to evaporate? Yes or no? No. So instead of having all those water molecules in the vapor, I only have less. Due to what? The sugar. Remember, sugar does not evaporate. So sugar is flooding the surface. So I don't have enough water on the surface to evaporate. So what will happen? I will have less water molecules in the vapor. Therefore, I have less pressure on the inner wall. So what happened to the vapor pressure due to the sugar? The vapor pressure will be doing what? Lowering. Can you see the picture? I have less water on the surface. Remember which particles evaporate? The ones on the surface. I don't have much water on the surface. Why? Occupied by the sugar. Can you see those sugar? I'm going to go like this. Everybody knows delta means what? Change. What kind of change do I expect due to putting the sugar? Lowering. So delta means the lowering in the vapor pressure. How much the vapor pressure is lower? That depends on what? The mole fraction of the solute. The more solute you have, the more lowering. Make sense? The more you put sugar, the more the pressure will be lowered. This is the vapor pressure of the pure solvent, the water. So if 1/4 of the particles are sugar particles, vapor pressure and how many particles are dissolved. How much lowering, that depends on what? Do you still remember what you mean by mole fraction? I'm going to put equal here, young people. Equal. Mole fraction of solute means the number of moles of solute divided by the total number of moles. What do you mean total? What's in the beaker? Water and sugar. Mole fraction of solute means the number of moles of the sugar divided by the total moles of sugar and water together. The more sugar we have, the more the change in the vapor pressure. That's Raoult's law. Young people, there is another way to write Raoult's law, and that's given to you at the bottom of page 19. Another way of writing it. We are telling you the new vapor pressure of the solution. The new vapor pressure depends on how much solvent is there. And that's also called Raoult's law. So why do you put node? P node. Node means what? The pure solvent. Like the water. Water is my solvent. So the new vapor pressure has to do with how much solvent is there. So if I still have 90% of the particles are water, then the new vapor pressure will be 90% of the original pressure. That is still Raoult's law. See, they're saying the same thing. The lowering depends on what? How much solid. The new vapor pressure depends on what? How much solvent is there. Please make sure you know the difference. The new vapor pressure depends how much solvent. The lowering depends on what? How much solute. Make sure you know the difference between them. We call vapor pressure lowering, I call it colligative property. Why? Depends on the concentration. Let's do the problem at the bottom of the page. Go ahead and read it, please. I'm ready to work with this problem. We want to know how much the vapor pressure will be lowered because we put sugar. Sucrose is sugar. That is equal to the mole fraction of sucrose times the vapor pressure of pure water. Do you still remember mole fraction means what? The number of moles sucrose divided by the total number, which is the sucrose and the water. This is mole fraction. Multiplied by the pressure of the water. The pressure of the water, they say 23.84. Young people, how do I find the number of moles? The grams of the sugar divided by the molar mass of the sugar. What would I get? Grams divided by gram per mole. What do I get? Mole. Thank you. Grams divided by gram per mole, I get moles. What else we have? 1,000 grams of water. Let's change that into moles. Mass divided by molar mass, I get mole. And the number of moles of sucrose, again, 100 grams sucrose divided by 180 grams per mole, that will give me moles. 5.5 mole water. 0.292 mole sucrose. That's mole fraction. All this multiplied by what? 23.82. What is the unit of mole fraction? Mole divided by mole, I get no unit. Mole fraction has no unit. That's the lowering in the vapor pressure. This is the lowering in the vapor pressure. Let's do part B. What is the value of the new pressure, the new vapor pressure of the solution? Yeah, I want to extend it. Would you kindly add part B? What is the value of the new vapor pressure of the solution? What do you do? What do you do, young people? The pressure of the water minus the lowering, right? Okay. Let's do it. The pressure of the water minus the lowering. The pressure of water 23.84, and it is lowered by 0.1254. Oh, did not really lower much. This is the new vapor pressure. It's a little bit lower due to what? Due to the sucrose. How many colligative properties we're going to discuss? 4 of them. We are done with one. Vapor pressure. The vapor pressure, what will happen to it if I put sugar? Will be lower. Remember that. The second colligative property coming up. I like to draw a picture again. Ready? The beaker, water. Yeah, I'm doing the same picture again. And this is solution. need the most of water, you need the most of sucrose. See me after that, okay? You will have to remember that. Don't let it go. See me after that. Now this is sugar solution. When you heat enough, I'm going to say it very slowly. When you heat enough to bring a lot of vapor, what is the vapor doing? Going up. The vapor exerting a pressure equals to the atmosphere. This is when the bubble can rise. Do you see that? You have to bring a lot of particles in the vapor to do what? What is the vapor doing? Have you ever boiled water at home? What is the vapor doing? Pushing up. What is the atmosphere doing? Pushing down. When you have enough vapor to push up equal to the force by the atmosphere, then the bubble will have the energy to rise. Look at the pressure of the atmosphere, big. Look at the pressure of the water, very small. It's not going to boil. So what do you need to do? You have to heat more. To do what? To break the bonds. So you get more vapor. One more time. The pressure of the water, vapor pressure is big. Look how this small the arrow. I have to make that arrow bigger. How can I make it bigger? You have to heat more to bring more particles into the vapor. More water particles into the vapor. Why? So the vapor will push up. When the pressure of that vapor up equal to the pressure of the atmosphere down, this is when the bubble has to rise. So instead of water boiling at 100, water will boil, let's make up a number, 104. Why? You have to add more heat. What does the heat do? Break the bonds. So water can escape. So what will happen to the boiling point of the water? The boiling point will increase. How much? That depends on what? How much sugar? The more sugar you have, the less the water has a chance to evaporate, the more you have to heat, and the boiling point will rise higher. Does the boiling point depend on the concentration of the sugar? Yes. We call that colligative property. Can you see that? Any property of solution that depends on how much solute you are dissolving, we call it colligative property. So, we are telling you the change in the boiling point. I'm going to put BP. Would you mind to put the board out there? Thank you. Delta means what? Change. What kind of change do I anticipate? Increase in the boiling point due to adding the sugar. That depends on, watch this, molality. What is the symbol for molality? Big M or small one? Small. My teacher told me to remove proportional, and if you want to put equal, my teacher told me you have to put it constant. That's what my teacher told me. The increase in the boiling point depends on the concentration. The more sugar you add, the higher the boiling point. This constant, you already have it. Do not write it, please. You already have it. We call it molar elevation of boiling point. Can you find it in your lecture notes? Can you see it right there? That's page 20. KB, no, write it again, guys, you have it there. KB is the molar boiling point elevation constant. And sometimes I like to ask my students, what does that constant mean? You say, oh, no, teacher, it's a constant. No, wait a minute, please. Every solvent has its own K. For example, for water, I want to make sure you leave the lecture understanding what the constant means. For water, the constant is equal to, they give me a number here, 0.52 degree for every molar. Wait, let me explain to you guys. The boiling point for water at 1 atmosphere, what should be the boiling point? Everybody should know that. 100 what? Degree. If you put 1 molar sugar solution, the increase in boiling point is what? Half a degree. So what will be the new boiling point? 100.5 degrees. That's the new boiling point. How about if you have 2 molar sugar solution? What will be the increase in boiling point? Twice that much. Thank you. Will be what? 101 point. How about, you got the idea? How about if I have 3 molar sugar solution? What will be the increase in the boiling point? Will be 3 times that, right? See? How about if I have, you got the idea? So every 1 molar, every time 1 molar, what's molar means? 1 mole. Every time you put 1 mole of sugar extra, what will be the increase in boiling point? 0.52 degrees. So, let's go back and read. They said K is specific to the solvent, which means what? Every solvent has its own value of K. Go up a little bit. Let's see how it is defined. K is defined as the elevation. Do you all understand what we mean by elevation? Increase. Elevation means increase in the boiling point of the solvent. Due to what? Watch this. Dissolving how many moles? 1 mole. What kind of solvent? Volatile or non-volatile? Non-volatile. Make sure the solute does not break further. If the solute, like sodium chloride, breaks further into ions, what will happen? The more particles, the higher the boiling point. So non-volatile, non-dissociating solute in 1,000 grams. Moles in 1,000 grams. What do you call that? Molality. So, will I be able to ask you, what does K represent? What does K represent? The increase in the boiling point due to what? Dissolving 1 mole of solvent. What kind of that solvent? Non-volatile, and what? Does not break further. Non-dissociating. Look at the very bottom, page 20. Oh, they're talking about freezing point. 1 m calcium chloride. Which one? What is the answer? You're so smart. Highest boiling point. Why? More what? More particles. How many particles do you get here? 0.2 m particles. Why? Sodium chloride breaks into sodium and chloride. How about calcium chloride? Calcium chloride breaks into calcium and 2 chloride. How many particles? 0.3 m of particles. What do you mean particles? Calcium is 1 particle. Chloride, I have 2 of them. These are 3 particles. So which one of these 3 will have more particles dissolved? Calcium chloride. You put 1 calcium chloride, how many particles do you get? 3. You put 1 sodium chloride, how many particles do you get? 2. You put 1 sugar, how many particles